Section 5.4 Interactive Assignment Objective 1. In a recent poll, a random sample of adults in some country 18 years and older was asked, when you see an ad emphasizing that a product is made in our country, are you more likely to buy it, less likely to buy it, or neither more nor less likely to buy it? The results of the survey by age group are presented in the following contingency table, and we're going to complete parts A through C. So here is the rows: more likely, less likely, neither more nor less likely, and here are our numbers for the individual age group. And then the columns represent the age group, and you can see that we have the total for each amount for the age group, and then we have a total amount for each more likely, less likely, and so on. Okay? So the first question is asking the following. It's saying, what is the probability that a randomly selected individual is 45 to 54 years of age, given the individual is more likely to buy a product emphasized as made in our country? So we need to take this a little bit slow here. Okay, so again, what is the probability that the randomly selected individual is 45 to 54 years old? So we're looking at the column 45 to 54 years old, and it says of age, and then given that the individual is more likely to buy a product, so more likely to buy a product which is emphasized as made in our country. Okay, so if I want to go ahead and continue this row to there, and then I'm going to continue the age to here, we can see where the value intersects. Okay, so it intersects at 381. So those are the total individuals in the age group of 45 to 54 that are more likely. In this case, more likely to buy made in our country. Okay, so we want to compare this amount with the total amount of the more likely. So what is the total amount of more likely? Well, we can see that the total amount is the following. The total amount in that row is 1362. So the probability that an event F occurs, given that event E has occurred, is called a conditional probability and is written by the following. We would say that the probability of event F is occurring, provided that E has already occurred. Now, the conditional probability rule states that if E and F are any two events, then we would say that the probability of event F happening, knowing that event E has already occurred, is equal to the probability of E and F divided by the probability of E. So what we want to find is, what is the number of outcomes of event E and F, meaning where do they intersect? So what are the number of outcomes where a person is more likely to buy in the age group of 45 to 54? Okay, well, we can see here that represents 381. So again, we want to find out the numerator, and the individuals more likely to buy and are 54 years old is 381. Okay, now we need to find out what is the total amount of individuals who are more likely to buy. So that is the number of outcomes of the individuals that are more likely to buy. Well, we know that that's 1362. So 381 divided by 1362 gives us a probability of 0.280. So that means that the approximate probability is 0.280, rounding it to 3 decimal places. Now the next question says, what is the probability that a randomly selected individual is more likely to buy a product emphasized as made in our country, given that the individual is 45 to 54 years of age? So that is in our second question. So what is it asking here? Okay, so we want to find out, okay, now what is the probability that event F has occurred, provided that E has already occurred. So we want to find the number of outcomes of E and F divided by the number of outcomes of E. So we want to find out what are the number of outcomes of individuals that are 45 to 50 years old and more likely to buy. So we're looking for, okay, what are the individuals that are 45 to 54 years old and are more likely to buy? Well, we know that that represents 381 because this is more likely and there's the 45 to 54. And we want to divide by the amount of the individuals, okay, who are 45 to 54 years old. So the number of individuals who are 45 to 54 years old are 557. So therefore, we're going to take 381 and then divide it by 357. And therefore, we get a probability of 0.684. So therefore, we're going to say that the probability is approximately 0.684. Now the last part of this question says, are 18 to 34-year-olds more likely to buy a product emphasized as made in our country than individuals in general? So we need to compare two probabilities. Okay, so looking at the two probabilities, what we're going to do is the following. Okay, we want to find out what is the probability in the first one of individuals that are 18 to 34 years old and more likely to buy. So what are the individuals that are 18 to 34 and more likely to buy? Well, that is 210. Okay, and we're going to divide it by the total of individuals that are 18 to 34 years old, which is 535. And then we're going to compare that to the following. We're going to compare that to the total individuals that are more likely to buy. So the total individuals that are more likely to buy is 1,362. And we want to find out what is the total of that amount, which is 2,249. And then we're going to compare those two. Okay, so we're going to go ahead and put those amounts in there. So we have 210 divided by 535, and we're comparing 1362 divided by 2,249. When we find the probability of this one, we get 0.392, and the total is 0.606. So that means the people in general are more likely to buy than the individuals who are 18 to 34 years old, because that probability is 0.39. Technically, this is 39.2% compared to 60.6%. So then we would say the following. We would say no, 18 to 34-year-olds are not so it's no, less likely.